All right, this continues with our videos on the academic challenge test. This is 2021, questions 11 through 15. You can see on number 11 it says there's $320 available to fence in a garden. Fencing alongside the road costs $6 per foot, and the other three sides are $2 per foot. So the dimensions are clearly, could be X and Y here. $320, maybe you say that's 6x plus 2x plus 2y plus 2y. Okay, the other three sides were all, $2 per foot. And so we might say that 320 equals 8x plus 4y. If we divide everything by 4, okay, that would be 80 equals 2x minus y. And then we want the dimensions of the largest possible garden. This is actually a calculus problem, but you can do this without knowing much calculus, so we'll kind of approach it that way. We'll say that the area here is xy. And so y, I didn't actually solve for it up here, I guess, but y is 80 minus 2x. Okay. Y is 80 minus 2x, and so we'll punch it in here. And so if I was doing this on an academic contest and I wanted to get an answer fast, I would go to my graphing calculator and I would type in x times 80 minus 2x, and then I'd find a window that works. I could use the answer choices as a guide, and maybe 0 to 40 for the x's, and then just sort of pick a big number for the y's and see if it works. And you get a picture here, and then you just ask your calculator to calculate the maximum, and you get your spider on the left side, and we call it a spider, and then you get the other one on the other side, and you'll see that x is 20. Okay, it's in a glare there. X is 20. There you can see x is 20. And so if x is 20, then y is 80 minus 2x, and so that's 40. And so our answer is 20 by 40, our choice C. On number 12, it says, what's the area of a regular hexagon with side of length 2, round to the nearest tenth? And so there's more than one way to do this. Regular hexagons are sort of nice because they break into 6 equilateral triangles. We had a problem on the previous video about a regular nonagon, and we approached it like 1/2 times the apothem times the perimeter, and that's true, and we could do that. But let's have a little different approach on this one just for fun. This is 2, okay, and so we have 6 triangles that are equilateral sided 2, and so the area that we're interested in is going to be 6 because there's 6 triangles. And then the area of an equilateral triangle is s squared root 3 over 4. So more on that in a second. But so our answer would be 6 times 2 squared root 3 over 4. If you plug that in on your calculator, yeah, the answer is 6 root 3, right? So that's 10.4. If you like, why is it s squared root 3 over 4? Let's talk about it just real briefly. So if this is an equilateral triangle with side s, and we drew in the height, this would be s over 2, and this would be 60, okay? And then the height is, the side opposite the 30 times the square root of 2, so s over 2 root 3. And so the area of that equilateral triangle is 1/2 the base, which is s, times the height, which is s root 3 over 2. And so you can see that that is, in fact, s squared root 3 over 4. All right, number 13. Number 13 looks like it wants us to do a little polynomial long division. So we're going to take x squared minus x plus 2 and divide it into 2x cubed minus 3x squared plus 8x minus 2. And so the question we ask ourselves is x squared times what is 2x cubed? And so the answer to that question is 2x. And so then we'll multiply 2x by all these things and put it underneath. 2x times x squared is 2x cubed. 2x times negative x is minus 2x, and 2x times 2 is is 4. And so this becomes 0. Negative 3 minus negative 2 is negative x. 8 minus 4 is 4. I made a mistake here. This is 4x. This is x squared. There we go. That's x squared. And so then we say x squared times what is negative x squared? Well, that would be minus 1. And so then we have negative x squared. I forgot to drop down this minus 2. So negative x squared plus x minus 2. And we're going to subtract it. Make sure you use parentheses in this case. Negative x squared minus negative x squared is 0. 4x minus x is 3x. Negative 2 minus negative 2 is actually 0. And so our remainder is 3x. So choice D. Number 14 says, what's the coefficient of the 7th term of the expanded form of x plus 2 to the 13th? So this is a Pascal's triangle problem. And so it would be 13, NCR, okay. And we want the 7th term. Remember, it starts with the 0th term, so we want 13 NCR 6 times x to the 7th, and then that would be 2 to the 6th, okay? 2 to the 6th. And so if you get that and crank that out on your calculator, 13 NCR 6 times 2 to the 6th, and let's hope that that comes out to one of our choices. 109824, how about it? That's choice C. On question 15 on the next page, a radioactive substance is losing 10% of its material a year to exponential decay. Determine the half-life. Okay, there's like a faster way to do this than what I'm going to show you, but I have a hard time remembering it sometimes. And actually, I have a calculator that does this. I'm going to show you, and you're welcome to programs that I have for this. But we'll do it sort of without the program first, and then we'll go from there. So it's losing 10% of material a year. And so I like to just sort of think about what are the points, okay? And so we might say something like, at time 0, we can just sort of pick a number. Let's just pick 100, like for 100%. We have 100 of it. And then at time 1, we have 90 of it. Okay, it's losing 10% of its material. And so then, and we're going to take longer on this than we would on the contest, but I'll show you a shortcut at the end. And so then we say, okay, y equals CE to the KT. All right, and so C is definitely 100, because when T is 0, y is 100. So we have 100 equals CE to the K times 0. So that's nice. So C is 100. And so then we say y equals 100 e to the KT. Now, we know that when T is 1, y is 90. And so we know that 0.9 would equal e to the K. If we take the ln, okay, so if we take the ln of both sides, the ln of e to the K, remember, is K. And so K is the ln of 0.9. So now my equation comes down to the fact where it's y equals C, well, we know C though, y equals 100 e to the 0.9 times t. And the question says, what is its half-life? Well, that's like asking how much time does it take for y to be 50. And so if we put 50 equals 100 e to the 0.9 t, then we would get 1/2. Notice the half-life. E to the 0.9 t. If we then took the ln of both sides, we would have ln half equals 0.9 t. And so then we're going to take ln half divided by 0.9. And that should give us our answer. So let's just see if we get one of those choices. ln 0.5 divided by 0.9. And we get this negative number. So that means that Coach DeNeve did something wrong. That's what that means. Where did I do the K? Oh, K is the ln of 0.9. Oh my gosh, Darren. ln, I'm way up here. ln e to the ln of 0.9t. Okay. And so then this is e to the, yep, so the ln of e to something is e to something. So this is the ln of e to something is something. So the ln of e, so this is the ln of 0.9t. And so a half ends up to be 0.9t. And so t is just a half divided by 0.9, and then 0.55. And that's not the right answer. Oh, I did something wrong. I did something wrong. Let's see what we did wrong. At times 0, we got 100. Okay. 0.9 e to the k, ln both sides. So k is ln 0.9. And so y equals e to the kt. Let's just do this. Ready? Y equals 100 e to the kt, but we're going to store, I have a feeling I just made an algebra mistake. Let's store in our calculator what the ln of 0.9 is. So ln 0.9, and we'll just store it as x. Okay. I could have stored it as k, I suppose. And then 50 would equal this at 100 e to the kt. And so 1/2 equals e to the kt. So the ln of 1/2 equals kt. And oh, there, look, ln. I think I forgot the ln over on the other side. Ah, good. So our answer is going to be the ln of 1/2 divided by our value for k. So let's see if that gives us an answer. ln of 1/2 divided by our value for k, which was x. And that's 6.57. Oh my goodness, that's choice D. All right, sorry we stumbled through that one a little bit, but we ended up getting it right. All right, that concludes this video.